Acha, Bismillahirrahmanirrahim. Now, at first, we need to understand the location of this point, okay? So, in a dipole, we have two opposite natured same quantity of charge, plus q and minus q, and they are kept at a certain distance, right? Now, at a point on the perpendicular bisector, okay? So, if I join them, and if I find the middle point of them, and at that point, if I draw a perpendicular, then this is going to be a perpendicular bisector. Now you take any point on this perpendicular bisector. Obviously, this point is going to be at equal distance from both of them, from both the charge. Okay. If you take at this point, the distance and this distance is going to be equal, right? Because this is the middle point of this straight line. Now, if you move up or down, okay, along this line, you are always going to be at equal distance from both the charges. Okay, so so the distance from both of them will be equal. Okay, that is why I guess they have used r plus r square plus l square. Okay, the distance is same. So now you are talking about the direction, right? You didn't understand what direction it is going to be. Since the magnitudes of E1 and E2 are equal, definitely as they are at equal distance and equal amount of charge, so the force that will be applied will be equal. Okay, the magnitude will be equal. So the resultant E will bisect the angle 2 theta between E1 and E2. Now, as you can understand, if they have placed minus Q here. I will show you as the figure it is in the book so that it is easy for you to understand. Okay. Now, if you place a charge here, a unit positive charge, then what will happen? Definitely, this is going to attract this charge, right? So the intensity will be towards this, okay, along this straight line. And if this is positive and this is positive, so it is going to repulse this unit positive charge in this direction. Now, what will happen? Let us say a force is acting here along in this.
Sir,
বলো
attraction and repulsion সবসময় কি perpendicular হয়?
এখানে পারপেন্ডিকুলার হবে
I mean, yeah, কি জানে straight line এ যায় exactly.
অবভিয়াসলি তুমি একটা জিনিস যে দেখো এখানে মনে করো প্লাস কিউ আছে, এখানে মনে করো -2 কুলম্ব চার্জ আছে, ওকে? সো দে আর গোইং টু অ্যাট্রাক্ট ইচ আদার, রাইট? সো অ্যাট্রাকশনটা হবে along this straight line. This one we can say from the Coulomb's law, right?
Okay.
Newton's gravitational law also says this, okay? The force acts along the straight line joining them or along the perpendicular distance between them, okay? Acha. So here the thing that I was talking about, if two forces are acting on a body, okay, 5 Newton and 5 Newton, the resultant we can find out, right? But what will be the direction? It will be, the resultant will be just at the middle, okay? It will bisect, the resultant will bisect the angle between them. The resultant will bisect. If the total angle is 60 degree, it will be 30, it will be 30. We can understand it, right? If it is 5 Newton, if it is 5 Newton, then the resultant will be just at the middle. If it was more, it was 10 Newton and it is 5 Newton, then this resultant will be more inclined towards the higher value of the force, right? But here what we can see, both the intensities are equal to each other. So as a result, the resultant will be bisecting the angle between them. So if I consider the angle between them to be 2 theta, 2 theta we are considering for our conveniency, then we can say that this is theta and this is theta, okay? 2 theta will be bisected. This is what they are saying. Is it okay, Jaman, till now?
Yes, sir.
Okay, so it will be making, the resultant will be making theta angle will both the direction of intensities, okay? With E1 also theta, E2 also theta. Achha, so the resultant E will make an angle theta with E1. Now dPr equal to PBA. Yes, they are saying about these two angle, okay, equal to theta are similar angle on the same base dPb. So PR and so PR and is parallel and হবে না বোধহয়. So PR is parallel to PR parallel to BA. Yes, PR will be parallel to BA. This is the line BA. Okay, and this is PR. Okay. At the beginning of the proof, they considered this one to be theta. Now, if you see, this is theta, this is theta. So they are alternate angle. So alternate angle becomes equal to each other when they are in between two parallel lines. So that is why PR and BA, they can be considered parallel. Okay. Therefore, the direction of electric intensity on the perpendicular bisector of a dipole will be parallel to the axis the dipole from the positive charges towards the negative charge of the dipole. This one we can understand from here. I will read the line again. We will try to match it with our given figure. Therefore, the direction of electric intensity on the perpendicular bisector of a dipole will be parallel to the axis of the dipole. See, this is the axis of the dipole. We know it, right? In a dipole, the straight line that connects both the positive and negative charges are known as the axis of the dipole. So the resultant direction will be parallel to the axis, and the direction will be from positive to the negative. See, this is positive, this is negative. So from positive to the negative, it will direct. Okay. From positive charges towards the negative charge of the dipole. This is what is written. Is the direction clear now?
Yes sir. Sir, একটা কথা স্যার, একটু আগে আপনি বলছিলেন যে ফোর্স পারফেক্ট মানে একদম স্ট্রেট লাইনে অ্যাক্ট হয়, রাইট স্যার? তো লাইন অফ ফোর্স যেটার মধ্যে ইলেকট্রিক ফিল্ডের মধ্যে যে লাইন ফোর্স, ওটার মধ্যে তো বেঁকা বেঁকা কার্ভ লাইনের ফোর্সও আছে।
ওইটা হচ্ছে যে ম্যাগনেটিক লাইন অফ ফোর্স। যেমন এটা আসলে আমি তোমাদেরকে একটা ভিডিও দেখাতে পারলে ফাইন হতো। এই ভিডিওটা আমি কয়েকদিন আগে ওদেরকে দেখাচ্ছিলাম, ওই যে গ্রেড 10 এর ম্যাগনেটিক ইফেক্ট অফ কারেন্ট একটা চ্যাপ্টার আছে না, কারেন্ট ইলেকট্রিসিটির পরে, যেখানে জেনারেটর, মোটর, ট্রান্সফরমার এগুলো আমরা পড়ি। ওদেরকে একটা ভিডিও দেখাচ্ছিলাম, একটা নতুন ভিডিও পাইছি। এই ভিডিওটার লিঙ্কটা আমি তোমাদেরকে দিয়ে দিব। এই ম্যাগনেটিক লাইন অফ ফোর্সটা আসলে কি, সেই জিনিসটা তোমরা দেখবা। যেমন এটা আসলে ভিডিওটা ছাড়া আমি আসলে বোঝানোটা একটু মুশকিল হবে। আচ্ছা ঠিক আছে, সমস্যা না। আজকে আমি তোমাকে ভিডিওর লিংকটা দিই, তুমি দেখো, তারপরে পরের দিন আবার আমরা একটু উপরে ডিসকাস করবো। ওকে
ওকে।
মানে একটা জিনিসটা যেটা করে কি জানো, আমি একটু মুখে বলার চেষ্টা করি, আমার কাছে অনেক ইন্টারেস্টিং লাগছে জিনিসটা। মনে করো একটা টেবিলের উপরে তুমি একটা ম্যাগনেট রাখছো, ওকে? তো এখন উপর থেকে আয়রন গুঁড়ো যদি এভাবে ছিটায় দাও, আয়রনের গুঁড়া মানে, ঠিক আছে, তো ওগুলো যদি ছিটায় দাও, তাহলে দেখবা যে এরা একটা সার্টেন লাইন অফ ফোর্স এর শেপে ওরা অ্যারেঞ্জ হয়ে থাকে। ঠিক আছে? আচ্ছা, এটা দেখলে বুঝবো আমার মনে হয়, অসুবিধা নেই। তো এরপরে বলো যে এক্সপ্রেশন ফর ইলেকট্রিক পোটেনশিয়াল এট আ পয়েন্ট অন দ্য পারপেন্ডিকুলার বাইসেক্টর অফ আ ডাইপোল। এতক্ষণ আমরা দেখতেছিলাম যে ইন্টেন্সিটি, এখন ইলেকট্রিক পোটেনশিয়ালের এক্সপ্রেশন। তো এখানে কোনো সমস্যা আছে?
না স্যার।
ওকে, বাকিদের কি
স্যার
খবর?
আপনি 89 পর্যন্ত পুরো পড়তে বলছেন না, ডাইরেকশন পর্যন্ত?
আমি 92 পর্যন্ত পড়তে বলছিলাম। আমি বলছিলাম আমি ক্যাপাসিট্যান্স অফ কন্ডাক্টর এখান থেকে স্টার্ট করব। করো নাই মনে হয় না? আচ্ছা, অসুবিধা নেই, আজকে পড়ে নিও, যদি সমস্যা থাকে পরের ক্লাসে আবার বলতে পারবা। ওকে।
ওকে স্যার।
আর খাদিজা, তাহমিনা, আয়শা, ঋতু, তোমাদের কি খবর? ঋতু কি আছে? হাসিনা পড়ছো? আয়শা, তোমার কথা শুনি নেই।
স্যার পড়ছিলাম।
পড়ছিলা তো কোনো ডাউট নেই? সব বুঝছো?
না স্যার, হ্যাঁ বুঝছি।
সর্বনাশ, তোমাদেরকে আসলে আমি কেন যে মাঝে মাঝে পড়াই আমি চিন্তা করি। তোমরা নিজেরাই সব পারো। উল্টা তোমাদেরকে পরের দিকে আমার ডাউট হয়েছে, আমি পারি না অনেক কিছু মাঝে মাঝে। আচ্ছা, তোমাদেরকে এখন থেকে আমি কিছু এক্সপ্লেন করার আগে জিজ্ঞেস করতে হবে। তো এখন আমি তো ভাবতেছি এগুলোও তো তোমরা পারবা, তো পড়ানো লাগবে। আচ্ছা আসো একটু ডিসকাস করি। ক্যাপাসিট্যান্স অফ আ কন্ডাক্টর। We already have a little bit of idea about capacitor, right? Whenever we store charges, in between two parallel plates. If you remember, we studied this in grade 10. Okay, two parallel plates, two parallel metal plates or conductor plates, we can say. We will store charges, opposite charges in between them. Then it will be considered a capacitor. Okay. Now the example of capacitor is, can anybody tell me an example of capacitor?
The light we use,
Battery.
lights.
Okay. Two parallel metal plates. Okay. Okay. The number of positive charges produced in here will be equal to the number of negative charges stored in here. Okay. And this will be, okay, we will take a look into this in details later, but at first let us talk about the capacitance of a conductor. Okay, what is a capacitance? Now we know that whenever we store charges in a conductor body, what happens? The potential increases. If it is neutral, let us say equal number of proton and electrons are there, so as a result what will happen? It will be neutral. It will neither be positively charged nor be negatively charged. So when it is neutral, what is the potential of a body?
Zero.
Zero. Very good. So when it is neutral, when a certain body is neutral, the potential is zero. Now the potential increases when we start,
Any charge decrease or increase.
whenever we put electron or take away the electron. Okay, so either we make it positively or negatively charged, it will have some potential then, right? Okay, so now what is the unit of potential?
Volt.
Volt. Very good. So now let us go through the definition of the capacitance of a conductor. The amount of charge required, we need a certain amount of charge, okay, to raise the potential of a conductor. If we want to raise the potential of a conductor, we need a certain amount of charge, right? Now how much I want to raise? By 1 volt or 1 unit, they said, okay, is called capacitance of a conductor. Understood? Okay, we know that to increase the potential we need a certain amount of charge. Okay, so to increase the to increase the potential by unit amount, okay, how much charge we need? So here we can say, let us say I increased V amount, and to increase this V amount I needed Q amount of charge. But to know the capacitance, I must know to increase the potential by unit how much charge I needed. So that will be Q by V, and that will be my capacitance, and which is expressed by C. Okay. Now, can anybody tell me what will be the unit of capacitance from here? Without looking at the book, please try to learn how I can say the unit of capacitance from here.
Coulomb volt inverse 1.
Very good. CV inverse 1, or we can say Coulomb per volt. Okay. Now this is also called Farad. Okay. 1F or Farad. See, it is written in the unit section. The unit of capacitance is Farad. If V is equal to 1 volt and Q is equal to 1 coulomb, then we can find capacitance C is equal to 1 farad. Oh, they have given the definition of 1 Faraday. Acha. Now, from here, what I can see, if Q is 1 coulomb and volt is 1 volt, then capacitance, this one will be equal to 1 Faraday. 1 divided by 1 is 1, right? Okay. So from here we can give the definition of Faraday. Can anybody tell me how I can give the definition of Faraday? We can say in this way, to raise the potential by 1 volt, how much charge we need?
1.
1 coulomb. Okay, if to increase the potential of a certain body of a certain conductor, if we need 1 coulomb of charge to increase the potential by 1 volt, then we can say the capacitance of that conductor is 1 Faraday. Is it clear?
Yes, sir.
Now from here, actually we can write the significance of any amount of Faraday, any amount of capacitance. If I tell you that what is the significance of 50 Faraday, not Faraday, scientist name holte Faraday bole gele, but it will be Farad only. Okay, so what is the significance of this? Or you might be asked, what do you understand by 50 Farad? Then you need to write, okay, see, 1 coulomb I can just replace by 50 coulomb, and 50 divided by 1, it will become 50. So I can write, to raise the potential by 1 volt, I need to supply 50 coulomb of charge. Okay, so then I can say the capacitance of that conductor is 50 Faraday. So if you understand this equation, from this equation you can give the definition or write the significance of anything. Okay, now these are important for 1 and 2 marks, that is A and B part of your creative. Okay, anybody have any doubt till now?
No, sir.
No, sir.
Okay, now as 1 farad is a large unit, last paragraph of 92 page I'm reading. Okay, as 1 farad is a large unit, generally a smaller unit, microfarad, is used. 1 millionth of a farad is called microfarad. Okay, I will show you, but let us try to understand why we need this microfarad. Now if I ask you what is the distance between two cities, you will tell me the distance in kilometers. But if I ask you what is the length of this marker, you will be telling me the length of this marker in centimeter, right? You will never tell me the length of this in kilometer. Common sense, right? So that is why we need the smaller units. Okay, in some cases we will be needing this smaller unit. Here Faraday, it is a very large unit. Okay, so that is why we will be using we will be using the microfarad. Microfarad. Now microfarad is written in this way, mu f. This is mu. Okay, now this one is equal to 10 to the power minus 6 farad. Okay, so if in question you get that 5 mu farad is your capacitance, then you can write this one is equal to 5 into 10 to the power minus 6 farad. Is it clear?
Yes.
This is
Yeah.
also called microfaraday. Okay, others are also there. Nano means 10 to the power minus 9, and pico is 10 to the power minus 12. Okay, micro means 10 to the power minus 6, nano means 10 to the power minus 9, and pico is 10 to the power minus 12. Okay, so picofaraday will be written in this way, pf, picofaraday. Okay, and nanofaraday, nf. So this is equal to 10 to the power minus 9, and this is equal to 10 to the power minus 12. Now if you notice 10 to the power minus 12, this one can be written as 10 to the power minus 6 into 10 to the power minus 6, right? So can I write it mu f? Can I write it in this way? Can you see the writing on the board? My marker
Yes.
is I guess. Mu f, right? Any doubt? 1 picofaraday is equal to 1 mu f, microfaraday. Any questions?
No, sir.
আচ্ছা,
স্যার আমরা মাইক্রো স্কয়ার বলতে পারবো না?
মাইক্রো স্কয়ার
হুম।
এরকম তো আসলে শুনি নাই, আমি দেখি তোমাদের বইতে আছে কিনা। এখানে মাইক্রো দুইটা তো অ্যাকচুয়ালি বলা যেতে পারা উচিত। কারণ কি? কারণ এখানে 10 টু দি পাওয়ার, এখানে চাইলে এটাকে আমরা কি লিখতে পারি 10 টু দি পাওয়ার -6 হোল স্কয়ার। তাইলে এটা হবে কি মানে মাইক্রো ফ্যারাড হোল স্কয়ার। চাইলে এভাবে লেখা যেতে পারে 1 picofarad is equal to microfarad whole square because -6 কে 2 দিয়ে মাল্টিপ্লাই করলে -12 হয়। এটা চাইলে লেখা যায়। ওকে, microfarad whole square. Okay. Then let us come to the significance. Oh, significance I already discussed. Okay. Now capacitance of a spherical conductor. Now let us try to understand it. Okay. Spherical means a circular object like football. Okay. So suppose there is a sphere of radius r placed in a medium whose dielectric constant is k. It is positively charged with charge plus q, then its potential becomes v. Okay, as it is charged, then what will happen? It will have a certain amount of potential and that is taken to be v. Hence its capacitance. Okay, to raise the potential by v amount, we had to put plus q amount of charge. So charge divided by potential is equal to the capacitance. This equation. Okay, here we put a small amount of q because that amount of charge has been put. The charge placed at the sphere would be distributed all over its surface uniformly. We know, right? If I do not apply any kind of force, then what will happen? The charge that is within the body, it will be distributed uniformly all over the body. So this is actually related to the equipotential of surface. Okay, if you remember. As a result, the lines of force emerge from the surface perpendicular in all direction. Yes, this figure we already studied, right? Okay, figure 2.19a. When these lines of force are extended backwards, they meet at the center. Yes, this is along the radius we discussed already. So then the lines of force will be similar. Thus the lines of force are same if the charge is distributed all over the surface or remain at the center. True. Okay, if they are at the surface, from surface it will come out perpendicularly. Now if I extend them backward, they meet at the center, so you will feel like they are actually coming out from the center or they are diverging from the center. Okay, so as a result, what I can say, I can consider all the amount to be gathered at the center only, and from the center the lines are coming out. This is just an assumption. Okay, we can consider this. So thus the lines of force are same if the charge is distributed all over the surface or remain at the center. Therefore, though q charge is placed at the surface of the sphere, it can be considered that the charge is concentrated at the center. Thus the potential at the surface of the sphere will be potential of the sphere. P is equal to -1/4πε0 k into q by r. Okay, so any charge that is on the surface, okay, it is at a distance of the radius from the center, so we can consider this potential. Substituting the value of potential in the above equation for capacitance. Yes, we have an equation for capacitance, that is C is equal to Q by V. We already found out our equation for V, so we will replace the value, and if you replace the value, you will see that Q and Q, they get cancelled, right? So as a result, what the equation becomes, C is equal to 4πε0 kr. Here, if the sphere is in vacuum or in air, then k is equal to 1. Yes, we know for vacuum or air, k will be equal to 1. So as a result, the equation will become C is equal to 4πε0 r. So this is an expression for capacitance. Okay. Do you have enough time to discuss on from 9:50 another class starts, right?
Yes, sir.
Okay. So electric capacitor, I would like to request you to go through. আরেকটা ক্লাস তো আজকেই, তাই না? At the 4th of
জি স্যার।
Sir.
So we will see you then, no problem. Okay.
Okay, sir.
Assalamu alaikum wa rahmatullah wa barakatuh.